You may be wondering why I've got the head bolted to the table. Well, the reason for that is I've removed the head and bolted on some 1, 2, 3 blocks, so that's 1 inch thick. And what I'm doing is I'm measuring the height from the center pivot point of the head to the base of the R8 spindle. Now, the reason why I've done that today is because people ask me, why did I get the SX3? Pay more, and the main difference is that the head actually tilts. Well, the main reason for that was that I wanted to tilt, and you may ask why. Well, if you ever plan to do any hobbing, now this is a hobbing cutter. It's for the XL belt profile, and it is a spiral thread, and as the head rotates, or as the cutter rotates, the job rotates one tooth for one tooth. But I'm just showing you this as an example of a form cutter. Now on the form cutter, it's actually stamped with an angle. The angle of this particular one is 1 minute, 33 minutes, 54 seconds. Now that's how accurately they've got that angle. And the reason for that is, and I will demonstrate with this side of this cutter, is that to get the profile correct, you must set it to the angle. Now, if this cuts directly this way, you'll get a flat. If you fed your job through that way, you would get the radius. But if you fed your job at a 45-degree angle, you would get part radius form and a part flat on the bottom form. So the form actually goes from that shape to that shape due to the different angles. So, same as this. You must tilt the cutter so as you get the correct shape you are after in the correct direction. The other mill I have is a horizontal vertical type, and the table actually swivels 45 degrees to the left or 45 degrees to the right. The idea of that is you put your hobbing cutter in the horizontal arbor, and the table is swiveled to the angle on the hob, and also if you're doing helical milling, it is also then swung over that extra degrees. So that's the reason why I purchased that mill. So I'm planning to do hobbing and form cutting on this particular mill in the vertical position. So I will hold the cutter in that position, then I need to tilt the angle. That is why I got the tilting head. If you are then going to put a spiral on a 4th axis, you then also have to tilt the helix angle. So it's a combination of the helix angle and the cutter angle. So okay, you've done that, but why am I measuring it? Well, as you know, with a normal cutter, you have your height, and if you want the center of the cutter, you know that may be, say, 4 inches from the end of the spindle. Your rotary axis might be 3 inches up, so you know where the center height is in your Z. But when you tilt the angle, your center height swings out, but also your vertical position is out. Now if you want to set it to the height, the center height of the bar, when it will be up here. How do you calculate where it is? how do you find the center of that cutter? Very difficult when you can't measure properly on that angle or that angle. So what you do is you actually measure that angle. So then you know that distance from there to there. Then if you swing it, say 2 degrees, you've then got a right angle triangle. You then know the distance across and the distance up. So then when you have set up your job in the normal vertical position and you've milled it and it's still in the 4th axis holder or any particular shape, you then just have to tilt it and calculate it, and then it may be 2 inches further across, so you move the table 2 inches. Maybe ½ inch higher, so you then adjust your Z height for the extra ½ inch. So then you can still keep all your G codes and you just add up the difference. So then you will know that the shape of the form is cutting along the center line of the job. Because not only does the shape vary, if you're up on the height or the lower, it then will cut a different shape because of the radius of the job. So I highly recommend measuring your head, and then you can use that calculation later. I've measured the height from there to there, I've measured the bore, and I've measured the pin. There's a 2.5 thou clearance between the pin and the hole, and I would take in consideration that the pin actually hits on the top of the hole, and so it is not in the center, it is up half of that clearance. So that is what I'll add to my dimension to get that correct angle. So hope that helps you understand a bit more about why you set angles to the cutters and to your helix angles and any spirals. And if you haven't done it when you're machining if you haven't done it when you're assembling your head, then I suggest you do it now. Thanks for watching.